you can graph these. You also have your cheat sheet, so you can actually write down all the characteristics of these graphs. But in the pre-calculus course, you actually have to do these without the use of technology and be able to just graph them, sketch them really, based on the degree of the polynomial. So we're looking at different graphs of polynomial functions and what they mean and how we can identify them. All right, so I guess the easiest one to start with, I'm going to start with the linear one. All right, so a linear graph, obviously a line, okay, can go up that way, can go down this way. All right, the equation for a linear graph, y equals ax, would be an example of it. Okay, so the things that we need to be able to do, number one, sketch it. Just a reminder, quadrants, because this is going to be important for us right away. So there's a little bit that's going to be brand new to you that you haven't done before. Number of x-intercepts. So the number of x-intercepts in this case is 1. It's going to cross the x-axis one time. Number of y-intercepts, also going to be 1. It's going to cross the y-axis once. Number of turning points. What we are going to look at, so this is new to you. So turning points is the first thing there's one of the first things. This is actually the first thing that we want to talk about in a second here. The degree of it, turning points, and end behavior. These are three things that we haven't discussed before. Those are three things that we haven't discussed before when it comes to graphing. All right, the degree of the graph is always the largest exponent on the equation. So in this case, the degree for a linear graph is 1. So it's the largest, the degree is the largest exponent on your x variable. That's the degree of the equation. The number turning points will always be 1 less than the degree. Okay, so new to you. So in this case, if the degree of a linear equation is 1, how many turning points are there?
0.
There's no turning point, so it doesn't turn. Okay? Now the end behavior for this graph is what quadrant does it start in on the left and what quadrant does it finish in on the right. So that's what the end behavior of the graph is. Now, what we are going to do, we'll look at the odd ones, but I'll do it for odd degree right now anyways. So for odd degree, meaning the exponent being 1, 3, 5, 7, 9, whatever. If my a is greater than 0, meaning that my a value right here is a positive. If a is a positive number, the end behavior for an odd function, or sorry, an odd degree, is 3 to 1. And we write it out with quadrant values. So meaning we use Roman numerals. So quadrant 3 to quadrant 1. So have a look at this graph right now. On the board, the A where A is positive is this one right here, this bottom line. Which quadrant does it start in on the left? Starts in quadrant 3 and it goes up to which quadrant on the right? 1. Okay. Now the other line is when A is less than 0. So what is the end behavior for it? 2 to 4. And if you're ever unsure, you just draw it out. Okay? Now let's look at a parabola. So we're going to look at a parabola. I'm going to start right here. there's a basic parabola where the a value is greater than 0. All right, looking at that parabola. First of all, what is the equation of a parabola? What's the standard one? Ax squared plus bx plus c, right? Basically. Okay? So what is the degree of a parabola then? 2. Okay, it's the highest exponent. So in this case, it's a 2, right? Okay. How many turning points does a parabola have? 1. Very good. Okay, there's my turning point right there. Now my end behavior. When a is greater than 0, so meaning when it opens up, what quadrant does it start in?
2.
2, and what quadrant does it finish in?
1.
So it's 2 to 1.
And that's for even.
That's for even. That's right.
Thanks. I should have wrote that up.
That's for all even ones. Okay. A is less than 0, meaning
3 to
3 to 4, yeah.
opens down. Three to 4. All right. The other things that we have to look at is the
Domain and range.
domain and range. All right. What's the domain for a line?
Find a line.
X is the element of both.
Very good. What's the domain for a parabola? Pardon me? No, that's range. X an element of all reals. All of these polynomial graphs, all the polynomial graphs will be X as an element of all reals. They'll go left and right forever. Okay? So, and again, you have to know how to write this properly. So you either write it in set notation or interval notation. You guys remember what interval notation is?
When I hear interval, I think of music theory.
So that would be interval notation. Negative infinity to positive infinity with open brackets. So we have to go back to grade 10 and grade 11 and start thinking about doing that. Okay. All right. The range. The range for an odd function. All right. So a linear line, a cubic one, quartic. Okay. Or quintic, sorry, not quartic, quintic. All right. So a degree of 1, degree of 3, degree of 5. Your range is going to be they're going to go down forever and up forever. Okay, so look at the line. Down forever, up forever.
Yeah.
If you have a cubic function, down forever, up forever. Left forever, right forever. That's a cubic function. The even degrees, you're going to have maximum and minimum values. Remember this?
Yeah.
So a parabola right here, this would be your minimum value. So your range would be y is greater than or equal to something. Okay? Or y, if it was here and it was your maximum, y is less than or equal to something. So we'll look at that a little more in depth as we go through. Okay, now flip over to page 158. Keep in mind, so these again are useful tips for you and how we have to deal with these things. When a polynomial function is in standard form, the maximum number of x-intercepts the graph may have is equal to the degree of the function. All right, so we have not written that down. The number of x-intercepts. The maximum is equal to the degree. Okay? All right? Now, with the x-intercepts, though, an odd function has to have at least one x-intercept. All right, now I'm going to look at, actually, let me start with the evens. So I'm going to look at a problem. All right, so equation number 1. How many x-intercepts?
No.
0.
Oh, yeah, there is. No.
No x-intercepts. Equation number 2.
There's always a bias.
1 x-intercept. Equation number 3. How many x-intercepts? 2. So what you have found is for the number of x-intercepts for an even degree, in this case is 0, 1, or 2. The maximum number being the same as the degree, the minimum number being 0. It's possible that you have 0 there. Let's have a look at an odd degree now. So there's y equals x cubed. How many x-intercepts? 1. That's the minimum for an odd degree. You have to have at least 1 for an odd degree. All right? It will always cross the x-axis. Yes.
How do we know that's odd?
How do we know what's odd?
Like the graph.
The graph?
Yeah.
Well, first of all, I know the equation is this. Okay? Second of all, you can't see it great right now. I'm gonna emphasize the turns in a second, but the number of turns is 2. So remember, to get the number of turns, it's always 1 less than the degree. So you actually count the number of turns and add 1 to it, and that's the degree of it. So in this case, if the number of turns is 2, all right, it's an odd degree. Okay? So, oops. All right, here's another example. There, so I really emphasize the turns there. So how many turns are there? 2 turns. Therefore, the degree is 3. How many x-intercepts are there here? 2. Okay? And then finally, how many x-intercepts are there? 3. So you can have 1, 2, or 3 in that case. Okay? Now, if you're unsure of yourself, you shouldn't be because you have a cheat sheet. But if you were unsure of yourself, I always draw the parabola and I draw the cubic function. That's the cubic function there. And then I can count everything out. I can change it and see and draw it out so I know everything. All right. The maximum number of turning points the graph may have is equal to 1 less than the degree of the function. The degree and leading coefficient indicate the end behavior of the graph. So that statement refers to this right here. The leading coefficient, A, determines the end behavior of the graph, which quadrants it goes from. Okay. The y-intercept of the graph is equal to the constant of the function. So in an equation such as this, the y-intercept is always that c value. Okay, it's the constant because you put 0 in for x. 0, 0, and then add c. So that's where my y-intercept is. My y-intercept is where does it cross the y-axis? Well, where x is 0. Linear and cubic polynomial functions have similar end behavior. We've already done that. All right, so let's look at a couple examples. Now, again, you are, okay. I'm going to tread water lightly here. You are allowed to use Desmos. However, what we are going to get into in 6.3 is modeling lines of best fit. And I find the calculator, the graphic calculator, to be better at modeling the lines of best fit than Desmos. Now, you can figure it out on Desmos, and it can be done, and we'll look at that. But the calculator actually does it, I think, a better way. So we have to look at how to do that. But that's a future you problem tomorrow. Okay, so let's look at the following questions here. Two examples to do. All right. F of x equals 4x plus 2. Determine the following characteristics of each function. All right. In the margin there, in your descriptions of characteristics of the function, include number of x-intercepts, y-intercept, and behavior, domain, range, number of possible turning points. Okay, first things first. What's the degree of this equation? 1. What's the name of this equation? Linear. Number of x-intercepts? 1. Number of y-intercepts? 1. And behavior?
3 to 1.
3 to 1. And behavior is going to be the one that you'll not struggle with, but it'll take you some time to get used to. Okay? So the end behavior for this graph, again, you've already written it out. It's an odd degree. A is greater than 0. So what's the end behavior? It doesn't change. 3 to 1, right? So this is 4x plus 2. So I go to 0 and 2, which is right here. I go up 4, right here, and then I draw my line. Okay? So that's graphing a line. Remember, I go y-intercept and then use my slope to tell me where I got to go, right? So 4x plus 2. Okay? We good so far? All right. Okay. What's the domain for this graph? For me?
X is an element of all.
X an element of all reals. What's the range? Y is an element of all reals. Okay. And what's the number of possible turning points?
0.
0. All right, good. Let's look at this next one. F of x equals minus 5x squared minus 2x minus 1. Okay. First of all, what's the degree on this guy?
2.
Degree is 2. Number of x-intercepts.
1.
How many does it have?
Oh,
2.
0. I don't know.
Why
Okay, what are the possibilities for this guy? What are the possibilities? 0, 1, and 2, right? So until we graph it, though, we're not going to be able to see it. Okay, unless we know what the vertex is, and then whether it opens up or down, we're not going to be able to see it without graphing it. So at this point, I would say sketch it.
But isn't it, because y is -1, right?
Yeah, but that only tells me what the y-intercept is. That doesn't tell me what the vertex is. It could go through -1 and still go above the line and below the line.
But then -5, that means opening up, doesn't it?
No, it opens down.
Oh.
Negatives down. Okay? So the possibility here is 0, 1, or 2 still as a possibility. So until I sketch it, I can't really tell. Okay, at that point, I would use technology and I would sketch it. All right. End behavior for this graph, 3 to 4. Okay, it's an a value that's negative. It's an even degree, so therefore it's 3 to 4. Domain for this graph, x and all reals, and the range for this graph. Yeah, y is less than or equal to the maximum value. We don't know what that is yet. Okay, and again, I would need to sketch it using technology to do it. Now, last year we thought we figured out ways of graphing this. Okay, we could have factored that and used our x-intercepts. We could have used completing the square to do it, getting it into the a x minus h squared plus k form. We could do all that. I don't need you to do that. You need to graph it on a calculator and then look at it, find your vertex, find your intercepts, whatever it may be. Okay, so that's the beauty of this class, is that you are to use the technology to find those solutions to help us. All right, so the number of possible turning points in this guy, how many turning points does this graph have?
1.
Has one. Has one. All right.
How did you know that it was a 2 to 3? 3 to 4.
3 to 4.
Yeah, because
It's an even degree, and your a value is less than 0.
okay. It's like 2. So 3 squared.
Even degree, a is less than 0, 3 to 4. You don't have these written down?
Yeah, I do, but I haven't mixed up.
Okay, we'll get that right.
I didn't know those both were even. I had one is even and one is odd. Those are both are even.
Yeah. Okay, does everybody in here, there's not too many questions for this. 6.1 and 6.2. Does everybody in here have a graphing calculator? Morning. Does everybody have their graphing calculator today? Yabo. Anybody not have the graphic calculator? Yeah, go get it. Go get it, please. Okay, on the graph, and let's go to page 162. So we are going to go through a method on how to graph using lines of best fit. Now, the next 4 sections, 6, 7, and 8, sorry. 6, 7, 8, next 3 sections. We are going to spend some time graphing lines of best fit. All right, and we have to use the statistics part of our graphing calculator. And there's a step process to how you want to do this. So what I want you to do is I want you to follow through, and we are going to write out to make your life easier, because it's going to be done over and over and over again. We're going to do this for lines, for polynomial functions. We're going to do this for logarithmic functions. We're going to do this for exponential functions and trig functions. So we've got to be able to do this well. All right, so it starts today. So writing down the steps in which you have to do this is going to be your most important thing. All right, okay, so the first thing we're going to do today, go open up your graphing calculator, clear your thing off, your screen off. And here's step number 1.
Numero uno.
Numero uno is right. Number 1. Hit stat.
Where's that?
Oh,
It's
for
like
crying out
right
loud,
there.
look for it.
It's like the biggest.
I hit it. I hit
It's spelled S-T-A-T.
The big button with stat on it.
It's right here. It's right under delete.
All right. Now, everybody's on that? Everybody's hit stat?
Yeah.
Okay. So number 2. And there's a number of steps here. So you got to hit edit. So hit enter on edit. Okay, so it should say line 1, line 2 at the top. Does it say L1, L2 at the top? Because if it doesn't, then I want to change your calculator.
It says L1, L2,
L1, L2, right at the top. We're good? Okay, now I'm going to go through this. This is probably the most frustrating thing I do with a class. Because you guys can't be quiet and you can't follow instructions for some reason. So do your best. Make it less frustrating for me today.
Yeah.
My standards are set so low for you right now, it's not even funny. Okay. All right. Okay, so here's what you have to do. This is a side note. Okay? So we want to clear L1 out. Now you have to do this right. Some of you, so follow the instructions that I'm going to give you because somebody's going to delete it and then it's not there and then you have to reset your calculator to get it there. That's a whole new process, so don't screw this up. Like I said, follow the instructions. Okay, or my kid would say, follow the constructions. Okay, so take your arrow, put it up on L1. So arrow up to L1. And then hit clear.
I did it.
Yeah.
Where's the bottom?
Now just wait.
Oh.
Just hit clear once and then enter. All right, now your line 1 should be blank, correct?
Mine says L1.
Did
you delete it?
No, it went like that.
What's the problem? Yeah, that's good.
It's the problem.
You don't have mine.
Balin's looks.
See, I set the bar so low and we've already messed up.
I did.
Yeah, Balin's looks weird.
Oh, go on.
Yeah,
Someone
please.
help me again.
Oh, clear?
No.
Is yours?
Enter?
Yeah, mine right.
Ian said access is weird too.
No, but I never had anything on the other one.
But it never happened.
Oh, then you probably did that.
Don't enter though.
Because I only have stuff in 2, but Lily, there's something.
I have something too.
Oh, there's something.
Are you supposed to have stuff in
I
hold
can't-
on?
Okay, listen. See, all I asked was you just follow instructions. That's all I asked. And we were already off the rails. That took 12 seconds.
I got mine.
That might be a new record. All right, now let's clear our line 2 as well. Can you manage that?
I already did that.
Oh, good, Haley.
Mine
Thanks,
doesn't have
Eli.
anything in anywhere.
Yeah, mine
just
doesn't.
leave it.
So up to line 2, all the same thing. Just switch line 1 with line 2.
Might
Follow the
have to cut
instructions.
that out.
I am
Yeah,
not
but
putting it
L's
back.
No
You
one-
can't figure that out.
Really, you're mid.
We have to do this
To a
every
different
time.
class.
Oh, yeah.
Yeah, man, you gotta do this
You
every
know
time.
what? Next to your outfit.
Okay, now I should have line 1 and line 2 completely cleared off. Yay?
Yay.
Okay, now what I want you to do is we're going to put in the years from this question. Okay, so what we're trying to do, this is a line, and we're trying to find out the equation of that line using technology. So on page 162, these are the winning times for the biathlon. So we're going to put in the times. So I put in 1964, enter line 1, 1968,
Oh, so
1976, 72,
this is going at the bottom. Yeah, does this
Yeah,
all
it
go
goes
in line 1 or?
You go in at the bottom, you click enter when you're done, and then it puts it in the line.
Oh, so I
put
Oh. You didn't clarify that.
Yeah.
Ooga.
I didn't
You've got
think I
some really
needed to,
smart
but okay. Are we good?
Yeah.
No.
1976,
Bill,
1980, 1984, 1988,
Where'd you get 88?
1992,
Wait. Oh, because
1994,
Oh.
1998, 2006, 2010.
Oh.
All right, so you should have 12 years entered.
Oh.
So at the bottom, when I'm done with my 12th year being put in, it should say line 113 in brackets, meaning that that's it. We're okay.
Yes.
All right, go to line 2. What do you suppose you're putting in line 2?
The winning
The winning times. So 80.4. Now it's imperative you put them in the exact spot that they're supposed to. 75.9, 74.2, 68.3, 71.9, 56.6, 57.6, 57.4, 56.2, 54.3, 48.4. All right, so your lines should match up. So when you're looking at the bottom there, they should both be 2010 and 48.4 should be the last things that you have in that line. If they're uneven, then you know you have an error. Okay. Once you've done that, set your calculator on your desk in front of you.
That's a weird step.
That's the answer.
Is this like a, do we have to do this step? Is this required?
It's just so that I can see that you're done doing it.
I'm doing the next
Just
question.
every time.
Eli, do not move ahead for nothing. That's also what happens, and then you get messed up, and then I'm not helping you.
Oh, look, you did.
Deacon, you got it in yet, man? Set your calculator down. Grayson?
Watch me.
Yeah, I think I just missed one though.
Jalen, you got him in?
Yes.
Set your calculator down. All right. So now we got to write down the next step here. Okay. So step 3 is that. Hit second mode, which is second function quit. Yeah. Go ahead and do that. So you should have a blank screen now in front of you.
You ruined it.
I still need
I did nothing of the sort.
Oh my god.
Okay, so we have a blank screen.
Then you just
We have a blank screen. Set your calculator down. I need to know that you have a blank screen. All right, number 4. Number 4 now. Okay, press stat again. Go stat again. Now here's where we got to get stuff going here. Okay.
Wait, bro, this isn't like a one and done thing.
No, this is a multi-step thing that you will do so often it'll come easily for you once you figure out this very simple process. Okay, now I got to go over 1 to calculate. So I've got to click on calc.
Bro, look at that.
Number 6. Now, here's the thing. You've got a list of commands there, let's say. You got var stats, var 2 var stats, median, linear regression, quadratic regression, cubic regression, quartic regression, and so on. Those are all going to be utilized.
Cool.
They're all going to be utilized at some point. But the question itself will tell you what type of regression we're using. So in this case, it says, use technology to create a scatter plot and use linear regression to determine this. Okay. So now what I've got to do is I have to use the right regression. And I'm only writing regression here. I'm not making it specific to this question because it will change. So I got to find the right regression. Now the question calls for a linear regression. So you're looking at number 4 there, right? Okay, so you go down to number 4 and hit enter on linear regression. Now that takes you back to your home screen and it should say linear regression at the top. All right, now, what's that? Yours is going to be different. I'm going to help you in a second. Okay, you're where you need to be. Okay, all right. You got the same as.
Oh, yeah.
Okay. Here's what happens next, and it's so important that you do the steps in the order in what we do. All right. Number 7. The 7th step here. You have to go. I'll explain it to you. Line 1, bless you. Line 2, and I want Y1. Now, how we get there? Okay. So this is a side note for number 7. I'm just going to put it over here. So second function 1. So second function 1. That gives you line 1.
Oh, that's like the yellow one.
Okay, so it should say line 1 now. So on my calculator right now, this is what I'm seeing. Okay, so far that's what I have. Yay? Okay. Now, comma, just above the 7. Okay, so on yours, you've got the line 1, line 2. You're good. You've got to go to store REQ. So just go down to where you get the store REQ. Okay? You're still good. Don't follow. I'll tell you when to pick this up now. Okay, now you're going to go. You need to put line 2 in there. So how do you think you got to put line 2 in there? Second 2. So let's do that.
Do we put a comma again?
Yes.
Wait, what?
Comma after comma?
Yeah.
Everybody go back and delete.
Do not delete anything.
I can't get a comma.
Arrow back.
Is that a comma?
Commas above.
Comma's above the 7.
You can't delete.
I don't know where my 2.
How do I put a comma in between them? I can, but I can't get in.
Anybody else not have this on their screen right now? Who doesn't have that on the screen? I gotta know. Like I said, my patience runs thin about this time of day on this thing. And it's early. Okay. All right, so we're at line 1, we're at line 2 right now, right? Okay, now, this is where it changes. This is where you have to pay close attention. All right, you guys have to do the same thing. So this is still for this number 7 area. All right, just below the left arrow is a vars button. We need to hit vars. Yeah. Hit vars. Okay, so everybody's hit vars. Now it gives you another menu. Okay, just below the left arrow button.
Right there. Very good.
My line.
Come on. Why not?
Are we good? Now, we have to go right to Y bars. So go over to Y bars. White, Y bars, no. Go right to Y bars. Can you follow that? We're good? Now all you have to do is hit enter twice, please.
Enter
On function?
1. Enter.
Just hit enter twice.
From
Oh,
Oh.
I forgot my.
Well, I might have went down and up.
No, it's on 1. It's just on
Yeah.
function.
There we go. Oh my goodness, I forgot my comment.
And then.
Okay, so now I should have Y1 here. Okay, we good?
Yes.
Anybody not have that? All good. Okay. Now I'm going to hit enter. We're far from finished.
What?
That is a.
Okay. So what do you see on yours?
Wait.
AX plus
equals negative 0.68217905.
I'm gonna mess this up so bad I'm gonna cry.
On store
Did you just hit
regression,
enter
but
on store?
they don't have what we have. Yeah, I know.
Did you hit enter twice?
No, they have a different calculator.
Yeah, mine just flashes calculus.
That's what mine is.
Yeah, that's what mine does.
We get it.
Okay, you wish you had a cool
I
calculator.
think you like calculated one question.
This test better be like 3 questions and that's it.
I think that's
Anything more I will try.
I wouldn't be surprised if you
Did yours work?
Mine is
Hit enter on it.
Same as
Hit enter on calculator.
no, it's calculated.
Yeah, you've got something wrong with your style. Okay, so
mine.
here, listen. This goes for everybody here. Because he's got a mistake, and you need to know how to fix your mistakes. He's got an invalid dim mistake. So it says error invalid dim. Means his light bulb's not working.
No, wait.
Okay, so what that means is his two lines are not matched up. Line 1 and line 2 are not matched up. So he's got to go back and he's got to check it. So he goes back to stat. Edit. Let's find out where you're wrong. You've got the same amount, but something's not right in there. I don't know what it is. 72. So you'll have to check that out. But everything else was done. Oh no, here's your mistake. Look at your top. What's that say? No, at the very top. Line 1, and then what's the next column? 3. Okay, so your line 2 has been deleted.
Right now, that was like the number one rule.
Okay, so what you got to do then?
Would be the very clear.
That means one of your numbers was wrong on your winning time.
And you can actually just change this column to 3. And it actually will. Okay,
Just click
so
that.
you're not changing. It's your Okay, anybody else have an error here?
No.
Get your phone away. Okay, anybody else have an error here? We're all good? Okay, now we are not entirely finished yet because this is their equation. That's what we were looking for. We're looking for the regression equation. So the equation is y equals negative 0.6822 x plus 1419.391. That's the equation of the line. So what? Now, the first thing that you want to understand is when you're doing a line of best fit, the line does not necessarily go through any of the coordinates. And I'm going to show you that right away. But it doesn't necessarily go through any of the coordinates. Okay? Now, I've got to carry on with this. So now that I have this, here's the next thing that I want you to do. I want you to hit y equals.
The
Top left corner.
Whoa.
Now, if you hit y equals, what equation just came up?
I didn't get an equation.
Hit y equals. That's
On
it.
the left, top left,
I should have got that equation.
very
Right?
top left.
Yeah, I found it. What do you want to add?
Yeah, I got this.
Wait,
It's on
Riley,
the top left.
yeah, that's the quick.
Okay, now listen. Listen, please. I need you not to.
Oh, mine's not.
Okay.
Wait, yeah.
Even incomplete thing. I don't know, I do.
I only have one. Holy, how many do you have?
3.
No.
I have one.
Hey, listen. This goes to everybody that's in here that's seeing more than one equation. There should only be one equation in y1. If there is not, go down to where you have a second equation and clear it. Don't delete, hit clear. So if you have more than one equation on there, hit clear. On the bottom, do not clear your first one. That's,
Why y2 just says y2 equals
It's that.
4?
It's the negative
You
0.6.
yes.
What does it say? Yeah, mine
What?
says y2 equals 4.
Okay, we'll clear it.
It's gone.
Okay, are we good? So you should only have one equation. Now, here's another new thing for you. Put the arrow up to the top where it says plot 1
Okay, it's on plot 1.
and hit enter.
It didn't do anything.
It did. You just don't know it
Yeah,
yet.
you just don't look at the numbers.
Okay, now, so at the top, have you done that?
Yes.
Hit plot 1. All right, now move it down back onto where it was, and that plot should be darkened.
Like the equal sign is dark.
Yeah, the equal
Mine
sign.
was
No,
And
the
the
plot 1.
At the very top.
Oh, yeah,
No,
the plot
it's-
one, like the title, plot one is dark.
Oh, it is now. I had to click it again.
Now it is, yeah.
Yeah.
Everybody, 100%.
Oh, yeah.
Told you this is a frustrating thing. It seems easy. Should be able to follow instructions. Okay. All right. So what I have gone and done now, okay. All right, is I have taken all of those stats, those plotted points. I have turned them into an equation, and now I'm going to graph them. So the next thing you're going to hit is graph. So just hit graph, top right corner. Those of you too impatient to look. Now, if you're like me, I got nothing. Nothing
Mine
showed
had,
up
like,
on
a little
mine.
line in the corner now. it's
Okay,
gone.
that's fine. It's fine. Just do not touch your graph. Don't change anything. Are we good so far?
Yeah.
Mine says again.
Yeah, okay.
Good
Good stuff. Perfect. Okay, now go back. If yours says error, go back again to where it's y equals and go down and make sure there's nothing in those lists. There could be something at like y9.
Or if it says like graph.
Nope.
Mine just gives quit, so I can't put photos.
Just hit enter. Y equals. Go down the list and see if you have any other equations in there. Did you have another one?
Yeah, I was in 7.
Yes.
I no.
Well, you still haven't fixed your invalid dim yet. So that you're out of luck right now. Okay, now here's how you get your graph to work now. So this is the next step. In the middle at the very top row is the zoom button. So you go to zoom. Okay. Now you could scroll up or down. I'm going to scroll up because I know it's on the very bottom. I want to find zoom stat. Now on my calculator, it's 9. So you want to hit zoom stat and you're going to hit enter on it.
Whoa.
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 It
Now,
did like an animation.
that's not an animation. That is a discrete graph with a line of best fit through it. You have now plotted all of the coordinates from that table that we did. We plotted all the coordinates for it. And it gave us the line of best fit. Now notice the line doesn't necessarily go through any of the coordinates, does it?
Goes through
But there'll be the same amount above as there is below that line. That's why it's called the line of best fit.
Yeah.
You know what? You're right. We'll just go with it.
Of course I'm right.
No,
Okay.
this is our first time.
All right. That's all I'm showing you today for this. We will come back and start the question off tomorrow, this exact question, because there's only one other step to do to solve it.
Don't turn it off or anything.
You can shut your calculator off now.
I'll just leave it on your back shelf.
I'm scared to touch it. I'm swapping the sleeve on for the day.
All right. There's one question on page 157 and 4 questions on 160, 161. Let's finish that for tomorrow, please. That was so much fun.